Post looking at our discussion on the EMI segment, now we are trying to try a new thing here. Let's assume the question changes. Assume that the interest rate changes to 11% after 4 years. So it's already 4 years since Ajay had taken that 40 lakhs of loan. And after 4 years, the interest rate changes to 11% from 12%. We keep hearing in the news items that RBI might cut interest rates and so on and so forth. Let's assume that cut in interest rate happens. Once that happens, what do we think is the likely outcome on the EMI? That's what we're going to look at as of now, which is assuming that the tenure remains the same. What happens to the EMI, right? So let's write this new tenure. Remember, this happens after 4 years, so you have 16 years left into 12 months, and I'll write new tenure in months. That's 192, and the new interest rate is going to be 11% by 12, right? That's 11% divided by 12. Now, what is the principal amount? Principal outstanding after 4 years should be the one in this cell. That's 37,52,450. After 48 months, post paying the 48th EMI, what is left is the principal here. That's 3752450. I'll take it up and put principal after 4 years and link this to the cell. And we find out the new EMI. So we look at this as the new EMI. That number will be given by, once again, the PMT function. Open this. What is the new rate? That's the new rate. What is the number of periods? 192. Present value negative of this number. Everything else is 0. What we get is about 41,615. So if interest rates happen to decline by 1 percentage point after 4 years, what is left of the EMI is that the EMI goes down by close to about 3,000 bucks, 44 becoming 41, right? So that's one part of the problem, where we are saying that if, let's say, the interest rate on the loan goes down, what happens to the EMI that we were looking at, right? Now let's actually change this a little bit, and let's say we want to look at new tenure. So let's actually introduce a couple of rows here, and I want to see what happens if, let's say, I want to keep the EMI constant. New tenure at constant EMI. Let's see if we want to do this. Let's say someone says that I can pay this amount. I don't necessarily need to change this amount, and so I can pay this amount. So what we're going to solve for is the tenure. The tenure, remember, in this equation, if we were to open the arguments, the tenure is given by this term called n per, right? And so it's logical that there should be a function like n per, number of periods, and we have the rate given here. We have the PMT, we have the PMT given here, that's the earlier EMI, and we have the present value given here, which is negative of this. And let's see what happens if they pay it at the same EMI. So new tenure is 166 months, which means you don't need to pay for 26 more months if you continue with the same tenure based on the new interest rate. So if you change the interest rate, you can either take a different EMI for the remaining tenure, or you can say I will pay the same EMI but for a different tenure. Obviously, if instead of 41,000 you end up paying 44,000, the likely EMI is going to be only for 166 months, because you're paying more and instead of 192 it's only for 166 months. This is also in, remember, months. So we have solved the question of changing parameters. If you have the tenure staying the same, then the EMI can go down to 41,615. If you think that EMI can remain the same, then the tenure goes down to, constant EMI, which is 166 months, right? Now, obviously in this case, the tenure has gone down. Well, let's say the rates had gone up by 1%. So if the rates had gone up by 1%, we would have used 13% by 12. Rate going up by 1%, assuming same EMI, increases your tenure from the remaining 16 years to approximately again 20 years. So you've already paid for 48 months, but this adds another 46 months if you keep the same EMI, if the rate goes up by 1%. So that's the impact of a 1% rate move that could come into this equation. That's how you look at the EMI equation. Once again, you're using the same set of functions, N per, rate, or PMT, to solve this set of equation.